All right, we're going to revisit a topic that we haven't seen in quite a while, but remember that if we have a function y of x, like f of x, right, it's possible that we could have each of those variables, x and y, depend on another parameter t, right? So x could actually be this function g of t, y could be a function h of t, and so then really when we write y of x, that really means y of x of t because they're both dependent on t. And so if we follow that process through now with the chain rule, if we wanted to find dy dt, right, we know that we would have to do, derivative of the outside. So this would be y prime of x and then of t, right? So that's what this is saying. And then we'd have to multiply by the derivative of x, right? And so this is just Leibniz Leibniz notation versus prime notation. And so if we wanted to solve for dy dx, we'd have to rearrange, divide both sides by dx dt, and we get this, okay? So that's kind of the idea. If we have a parametric curve and we want to find dy dx, we might have to find dy dt, so derivative of y with respect to t first, divide that by derivative of x with respect to t. And so here we have a couple examples. We want to find places where the tangent line is horizontal, right? So the tangent line would be horizontal in dy dx, I'm sorry, dy dx is equal to 0, okay? So I need to go ahead and find like x prime, which is dx dt, 6t squared plus 6t minus 12, okay? And then y, I could do it, I really just need dx dt, but actually I need this one anyway, dy dt is equal to 6t squared plus 6t. Okay, so then when I do dy dx, right, it's the quotient of dy dt, 6t squared plus 6t over 6t squared plus 6t minus 12, which is dx dt. Okay, so then for horizontal or vertical, so for horizontal, I would set the numerator equal to 0. So this would be 6t squared plus 6t is equal to 0. Factoring, I would get, 6t and then t plus 1. So then I get t is equal to 0 and minus 1. Okay. If I follow that through, if I put in 0 for t, I end up with the coordinate 0, 0, 1. And if I put in the value of t as -1, I end up with 13 and 2. Okay, so I get those places where it's horizontal. Vertical is similar. You get this. Okay, so vertical for where the vertical where the tangent is vertical, you'd have to set the denominator equal to 0, and you get t is equal to 1 and -2, which gives those points. Okay. Finally, the equation of the tangent line. Yeah. Okay, so then you need to find the slope and a point. You already have a point, so you just need the slope, which is dy dx, right? This is actually then, since these are given parametrically, dy dt over dx dt. Okay, dx dt or dy dt is 8, nope, just kidding, 6t squared. And we get this as 6t. Simplifying, I just get t. And so then here, I know the slope of the tangent line is t, but I don't know the slope exactly. But what I can do is look at 3t squared plus 1 and 2t cubed plus 1 and set those equal to 4 and 3 respectively. So the x and y components set them equal to the corresponding parts, and solve that system of equations. And actually what I can find is that t equals 1 can work. So then I can say that my tangent line, it can be expressed in point slope form as y minus 3 is equal to 1 times x minus 4. Okay, and that can be the equation of the tangent line. All right, so there we go. We've gone through parametric equations along with derivatives of trigonometric functions and composite functions in this video series. Have fun with these.